this is an example of a related set of samples. These can happen when you've got an individual that has got a before and after. So the reason for doing related samples tests is that you're trying to reduce experimental variability using this process of blocking or pairing. The example that we've got here is about enjoyment of chocolate at 2 different times of the day. So you've got an individual and you ask them for their opinion twice. A similar experiment would be if you've got 2 different people doing grading of the same tumour. They're not independent because it's the same tumour that they're looking at, and the same if you've got first and second markers and you want to see if there's a difference in how they grade a piece of work. They're both looking at the same piece of work, so it's not independent samples. It's not independent collection of data. Now in this case you ask them at 7 o'clock in the morning, you ask at 6 o'clock at night. This was probably a fairly popular study with students who are getting free chocolate, though I'm not completely sure that at 7 o'clock in the morning I want to be woken up and given chocolate anyway. So the first person doesn't particularly like chocolate ever. Not at 7, not at 6. So they've got a difference of 0. It doesn't really matter because they're not very useful for doing the data analysis. Differences of 0 just disappear. The next person, 7 o'clock in the morning, they're not having it. They're not keen on chocolate. But by 6, they've picked up and definitely it's doing something for them now. The next person, they wake up and they give me chocolate. So they've got a great liking at 7 o'clock in the morning, but probably by 6 o'clock they've eaten so much that they can't eat even another chocolate button or wafer thin mint. They don't want to see chocolate anymore. In this case we've only got 7, so it's not a huge data set. But what SPSS is doing is it's looking at the differences between the scores in the T. Different times. So you've got a difference of 3, -4, 3, -2, 3 and 6. You then want to rank the differences. Ignore the differences of 0 because they're pointless. So the smallest one is going to be given the rank 1 and that's a difference of 2. You then have 3 ranks which are ranked 3 differences which are 3. So that would be the 2nd, 3rd and 4th rank. So you average that ranking of across those 3 numbers, so they all get rank 3 because that's the midpoint of 2, 3 and 4. The next largest one is a difference of -4, so that gets a rank 5, and the next one is a ranking difference of 6. So you rank those based on the magnitude and size, ignoring their sign. You then put the signs back on, so there are 2 that were negative numbers, they become -5 and -1, all the others are positive numbers. Then you look at the size of the totals for all the positive ranks, the totals for all the negative ranks, and you pick the largest of those 2 numbers to be the test statistic. Now it used to be the smallest, but SPSS has changed the way it does its evaluation and calculation of the p-value, so the test statistic is now the largest of those 2 numbers. So for the chocolate example, the sum of the positive ranks is 15, negative ranks is 6. As I said, when I worked through it originally, I was using a t calculated of 6 to go to the tables. The t critical is 2 for n equals 6 and p equals 0.05. So in this case, unless all but one of the smallest rank values were positive, it was impossible to find a significant difference. When you have very small data sets, it's very hard to find a significant difference in ranked methods because you need to have a very large difference between the ranks for there to be any significance. This is what the data looks like in the variable view. There's 3 columns, one of which is pretty much redundant and not needed. It's just a label which is student. You've got morning and evening, which are the 2 things that actually matter. This is the data set itself. So you go to analyze, non-parametric tests, and in this case related samples. You get a wizard which is the same sort of format as you got for the unrelated samples. So in this case, first thing is the objective. Can be done totally automatically, or you can customize it. Next, you need to choose the fields. So in this case, the only two fields, the fields that are important are the ones that are paired together. So this is the morning and evening. Notice that the data looks completely different when it's paired data, in that for unrelated samples, you have one column which contains the numerical value and one which contains a grouping. We have paired data, matched data, which is related to each other. Each of the related values has to go in a separate column. So you've got one column for morning, one for evening. You can only pick two of those. You can only have two related fields. You can't have more. Then you go to the settings to pick which test you want to do. It will go completely automatically. As I said, if you've got there's some cases where you might want to do a McNemar's test instead. You run the test on the fully automatic and it tells you the median of the differences between morning and evening equals 0. That's your null hypothesis, that there's no difference in preference in the two different times. You've carried out a related samples Wilcoxon signed ranked test. That's the right test, it's done it correctly. You've got a p-value of 0.340, which is not below 0.05, so you retain the null hypothesis. Go down and look at the summary table of how it carried out the test. There's the test statistic of 15, which was the sum of all the positive values, all the positive ranks. It's given a standardized value, don't worry about those things. The only other thing you need to look at is the p-value, which is 0.340. You've got a histogram of the output, so you've got the negative differences and the positive differences. If you look at them, while there are more positive differences, it's not such a large amount that it becomes clear and significant difference between the two. And I just wanted to show what the legacy output looked like when it was taking the smaller rather than the larger one for calculating the test statistic. So in the legacy dialogues, what it looks at is it says the sum of the negative ranks was 6, the sum of the positive was 15, and it gave you the asymptotic, the p significance, the p-value of 0.340. That's just there for those that end up accidentally using an older version of SPSS to show that you're getting exactly the same results. They've just slightly changed what the test statistic is.